Hello! In the next 15 minutes, I'll present you the new features of BricsCAD Mechanical version 22 using a new model we created. It is a fountain, which has a hexagonal shape, and we plan to show you how BricsCAD Mechanical can be used to properly place it near the Hexagon PPM building in Huntsville, Alabama. First of all, we are searching for the best place for our fountain using a civil terrain model of the Huntsville 305 site. After placing the fountain, we shall connect it with the pumping room. The equipment of the fountain and the pumping room was designed in BricsCAD Mechanical using the powerful features to enable fast development of products which include rigid pipes. These features are based on the rich library of pipes and fittings of different standards, SME, DIN, ISO. All parts in the library are parametric. They can be smartly connected to each other. In version 22, we extended the library with valves in ASME and DIN standard. It now includes angle, ball, check, gate, and globe flanged valves of different size. In BricsCAD Mechanical version 22, we also enabled even more powerful automated workflows for pipe design. Top-down approach allows product manufacturers to significantly reduce the design time in case a pipe system is designed from scratch. For that, we use BricsCAD BIM technology available in BricsCAD Ultimate product. We first draw polylines that represent pipe routes, and then we use BIM apply profile command to create flow segments and fittings. But BIM piping model cannot be used for fabrication because it lacks many details. These details can be added with BricsCAD Mechanical. Let me show. Here we use a new BM convert command which automatically converts BIM flow segments and fittings into a mechanical assembly consisting of piping standard parts of the most appropriate size within a given type. So now it is a regular mechanical assembly which will be embedded with additional mechanical parts and then connected to both the fountain and the pumping room. A mechanical model should be fully detailed to prepare its fabrication. In particular, we have to add flanges to it and properly connect them with pipes and opposite flanges. Flanges are inserted by dragging them from the library panel to the model area. Using the smart mode of BM insert command, we automatically resize the inserting part by copying expression for its parameters from the target part. The command also generates assembly constraints, which are needed to maintain the piping connectivity during direct and parametric editing of the assembly. But if we have to connect parts inserted previously, we can use BM connect command. Similarly to BM insert, it properly resizes the connecting parts and generates assembly constraints for them. So you can see how piping parts are automatically resized and moved to the appropriate positions. Note that pairwise connectivity between piping parts is not broken after this operation. Imagine the amount of work needed to create the same model with manual manipulations. Here you can clearly see how BricsCAD Mechanical can speed up typical design processes. Fixing collisions between pipes and fittings is very easy. You can move the collided parts or edit their coordinates. Thanks to assembly constraints, other parts are moved correspondingly without losing connectivity between them. Piping assemblies in BricsCAD Mechanical are parametric. To control the size of pipes and fitting of a particular pipe spool, we should select all parts in this spool and link their size parameter with the same global parameter. Similarly, we can link other parameters, for example, rating for flanges. From now, these global parameters can be used to change the size of all parts in one or several piping spools simultaneously. But flanges should be also connected with bolts or studs. In version 22, we implemented a new option in BM Connect to automatically insert studs and nuts which connect couple of flanges. The user can configure which particular types of standard fastener should be used for a bolting assembly. It is also possible to insert a particular gasket between flanges. The generated bolting assembly is fully parametric. It is controlled by the flange size. If you change it, then the size of bolts and their numbers is also changed automatically. So your model becomes fully detailed and still parametric. You can make changes to it. Of course, you can easily copy bolting assemblies to other flanges. They will adapt to their size automatically. Again, you see that BricsCAD Mechanical version 22 saves plenty of your time to get a fully detailed mechanical model with pipe and parts with just few clicks. Let's now examine other new functions of BricsCAD Mechanical version 22. One of them is a game-changing possibility to consider 3D solids as well as regular and parametric block and external references as mechanical parts and assemblies. It significantly increases flexibility in assembly design, as we'll demonstrate later. To use it, we have to switch mechanical block setting on and call BMech command. And now we can use regular xattach command to insert an external subassembly represented as a native XREF entity. You can see the internal structure of this XREF subassembly in Mechanical browser. Mechanical data exchange has been always in the focus of our attention. Using Communicator for BricsCAD, you can import and export models in different native and neutral file formats. Sometimes this process can take a long time, but now you should not wait for the conversion to be finished, because import and export are done in background, allowing you to continue to use BricsCAD in parallel. Moreover, for some formats it is now possible to import graphical representation, which allows you to start to work with the imported model immediately. As soon as the import is finished, this graphical representation is replaced with real geometry. This engine, imported from CATIA v5 format, can now be inserted into our assembly. However, it interferes with some other parts. Fixing these interferences is not an easy task, because it requires to change part geometry in the assembly context. But because frame subassembly is an XREF and its parts are 3D solids, this editing is perfectly possible with standard refedit command. In a refedit session, we can use the rich direct editing toolset of BricsCAD to modify the geometry of the nested part with snapping to other parts. In this particular case, we first change the thickness of the plate to avoid the interference, and we will move mounting holes to the proper position, and finally we'll increase the overall plate size. This is a clear advantage of new Mechanical Blocks mode. Please note that in BricsCAD Mechanical version 22, this mode is experimental and disabled by default. We plan to adopt several standard commands to it and finally migrate to this representation of assemblies in version 23. By closing refedit session, we update the external DWG file that represents the plate subassembly. Now we can insert the fastener into mounting holes. We are doing that by copying existing bolts with snapping to the center of circular edges. And that's it. You can see that assembly editing with imported parts can be done much faster in BricsCAD Mechanical version 22. Let me demonstrate you another new feature of assembly modeling toolset in BricsCAD Mechanical version 22. You know that every mechanical part and assembly has built-in properties such as type, name, description, or material. But now you can also define your own properties such as manufacturer name, cost, delivery date, and so on. To do that, we have to define a name property set with bmProperties command, also accessible from Mechanical browser, and then add properties to this set. Each property is defined by its name and type, boolean, integer, real, or string. Now we can set different values of these properties for different parts and subassemblies. In our example, we specify manufacturer name, cost per unit, and also cost per kilo for different standard and custom parts in our assembly. We use multiple selection to assign the same value to the properties of different parts. Please note that custom properties can also be imported from other mechanical file formats, such as Inventor. Now let's see how these custom properties can be used for preparation of technical documentation. We start with generation of drawing view of PAM frame subassembly. These views will be annotated with the corresponding bill of materials. And the first new feature of BOM Manager in BricsCAD Mechanical version 22 will never remain unnoticed. It now contains thumbnail images of every component. These images significantly simplify the understanding of your assembly. You can choose a particular graphical style for these images and adjust their size. These images are stored in separate graphic files referenced by your DWG file. Another new feature of BOM Manager is less evident but very useful. You can filter BOM table by a particular drawing view, so only components represented in the selected view will be listed in your BOM. And of course, the newly defined custom properties can be used in BOM by insertion of the corresponding columns. But not only. You can also create evaluated columns using custom properties. In our case, we define the cost of every component as the sum of its cost per unit and the product of its mass and cost per kilo. This formula combines both built-in mass property and custom properties. The formula editor of BOM Manager significantly simplifies the job. Its auto-completion feature doesn't require you to fill the full property name. You can also select the name from the drop-down list of properties. As we know the cost of every component, we can now easily compute the total cost of our assembly using the footer row that automatically sums up the cost of all components. But why do we do that in BricsCAD and do not use a spreadsheet software? Because our goal is to put the BOM table at the layout sheet, which will be automatically updated when we change the structure of our assembly, geometry of each part, or their native or custom properties. Let's now examine one more B22 feature of BricsCAD Mechanical. Of course, the possibility to add dimensions to drawing views is not new. Let me just remind you that these dimensions are associative. When your 3D model is changed, your drawing views are regenerated and your dimensions are recalculated automatically. What is really new in version 22 is the possibility to add dimensions to isometric views with automatic alignment according to the geometry. Moreover, these dimensions display true value measured in 3D space. At the end, we automatically annotate our drawing view with balloons, which represent the position of every component in the BOM table. In version 22, we significantly improved the performance of this useful tool. One more improvement relates to the drawing views with interferences. Usually the part should not interfere, as well as should not interfere the bodies of multi-body parts, but in some practical cases some small interferences are acceptable. However, hidden line removal algorithm used for generation of drawing views in BricsCAD does not detect edges of interfered bodies. So in version 22, we introduced a new property for drawing view which allows to display interference. So, as you can see from this short session, in BricsCAD Mechanical version 22, we extended assembly design, drawing generation, and data exchange toolsets with many new functions which will help you to design better products faster. Thank you for your attention.